Hey, so I'm glad you're back for some more math practice, because if that's the case, that means that you're starting to leave the beginner level of understanding quadratics. And so what that means for us is that the skills required to understand the concepts from now on is probably going to be the last 20 or so ideas that we've been discussing. So I would not recommend that you move on forward if you have a few questions on the last 20 ideas. All right? Otherwise, always go back and repolish your skills on those first 20 videos and then come back to this one and retry it again if you're a little confused. So having said that, let's continue our exploration. We want to continue and gain some more experience, collect some more XP. So let's see how to do that. This is really continuing the idea from the last time, all right? So that's why understanding the three forms of quadratic equation is very important. That's what we're going to do in the first part. Letter A, identify which of the three forms. Letter B, this is the same thing we did. Sketch each parabola and label 5 points. We've done a lot of that through so many videos. And then this one right here, letter C, is because the emphasis of this video is going to be vertical stretch and compression, and I should probably also emphasize, is there a reflection? Sometimes we have a reflection vertically across the x-axis. All right, so let's also keep that in mind. All right, and I don't know if I'm going to write all of it. Let's check it out. Let's start with letter A. What do you notice about the first equation right here? Give you some time to think about it. The second one here on the right, and then the third one below in the middle. All right, if you need more time, pause it, but I'm going to start to write things about it. So I know for sure, for me, when I see this, immediately I recognize something times something. So that must be X Intercept form or factored. I'm going to start using that actual name, factored form. But if you wrote X Intercept form, that's correct. So number one, we know it's factored form. What else do we know about it? Oh, we're going to do the letter B, the 5 points below. So then we think about the vertical stretch or compression. Let's look at that vertical scale factor. You think about it. All right, so one of the things that I notice is the negative, and the negative tells me there's a reflection, vertical reflection. Vertical reflection. That means it reflects downwards. And then we know that we ask ourselves, is this number greater than 1 or less than 1? In terms of its absolute value, just the 1/2. It is less than 1, so this is a vertical compression. That means the y values are smaller than the actual parent function. All right, so just keep those things in mind. All right, I won't be writing them below when we graph them, but that's what's going on. If you were able to identify these three things before graphing them, you're in great shape. You're ready to graph this. Just a little bit more algebra that's required. Next thing is, what do you recognize this form to be out of the three forms? Immediately, I recognize is the something squared. Something squared, but it's a perfect square, not like this something square. There's no perfect square with it along this 32x. So I recognize that this is vertex form. The easiest thing to find here is the vertex. Next, I look at the vertical scale. The positive means there's no reflection. So this is a graph that curves upwards, as opposed to the first one that curves downwards. That's what the vertical reflection implied. And then we look at its absolute value. Is the 4 greater or less than 1? It's greater, so therefore this is a vertical stretch. All the y values here are larger than the parent function. If you identify that same thing, you're ready to graph this, and it won't be that much difficult for you to understand what's going on. All right, and then this last one is, all right, so if we already had factored form and vertex form, this one has 3 terms and it looks very different than all the others. This must be standard form or Y-intercept form. However you wrote it, that's correct. And then we know that we're going to look at the A factor. It's greater, and that's ignore the, well, let's take care of the negative first then. If it has a -8, just like this parabola here, we know that it has a vertical reflection. And we know that now we need to compare this 8 in its absolute value in terms to 1. So is 8 greater or less than 1? 8 is greater, so therefore this is a vertical stretch. But it's also been reflected vertically. Vertical stretch. All right. We didn't need to write these things down, but it was good for this, for the purpose of collecting XP and verifying that we're on the same page. Because once I graph them, I'm not going to write this down, but I'm going to think about it. And you should do that every time you see one of these three forms of quadratic equation. If you don't write it down, just at least think about these possibilities of transforming your parabola. So let's see. Let's get started. And I recognize that this was factor form, and hopefully you did as well. So we're going to start with x-intercepts. And x-intercept is when x equals 0. So I'm not going to show the work like I did in the previous video, because otherwise, what's the convenience of going through that? I'm just going to go straight to the answer. It's going to be a -8. I did it in the last video to refresh your algebra if it was rusty. So go revisit the last one if you want to see more work. It was a -8 and also an x-intercept of 4, 0. Those are the two. Then I would probably try to figure out the y-intercept. And here I may show a little bit more work, but not as much. And we know for the, oh, let's correct this. I probably said y equals 0, or I hope that I did. But I wrote x equals 0. For x-intercept, the y value is 0. And for y-intercept, x equals 0. So that should be the correct thinking. All right, so when we have that, we get that y equals -1/2 times 8 times -4. You verify that that's correct. And then whatever order you want to simplify, you should get a x value of 0 and a y value of positive, because negative times negative is positive 16. All right, we have 3 points so far, so I'm going to start doing some plotting. That's the order in which I prefer to do these. So I will start with a -8 somewhere out here, +4 somewhere there, maybe a little bit further out. Yeah, somewhere right there. So we know that the vertex is going to be somewhere in the middle of those two, as well as the line of symmetry. 4, 0, -8, 0. And I probably will figure out what the vertex is before I plot this 0, 16, just so it fits my picture better. That way I don't have to do any erasing in case it's off. That's my thought process. So let's figure out the vertex. And let's see if you can figure out before I do. The x value of the vertex occurs at the midpoint of these two. The midpoint of -8 and 4 is going to be x equals -2. X equals -2. Verify that for yourself. The way we did that is -8 plus 4 is -4. Divided by 2 is -2. We took the average of those two. So we need to evaluate the parabola at x equals -2. So somewhere up here, I believe. Yep. All right, let's do all the work on the right side. So if you wanted to use the notation of function notation, that's fine. Otherwise, just do whatever we were doing in the past. -1/2 times, I'm probably just going to go straight to the answer. What is -2 plus 8? It is a 6. And what is a -2 minus 4? It is -6. So hopefully you can simplify that quickly and realize that it's a positive y value. And it is 18. So the point should be written as -2, 18. And that should fit with our 16. You see how that's, if our y-intercept would have been something larger than 18, then you know something's off and it doesn't fit this graph. But it looks like we're going to sketch a pretty nice parabola here. Something like that. Where that's the x-intercept of 4. And, oh, I forgot to label y-intercept of 0, 16. And very easily, we can plot the matching point, or the point of symmetry, where the y value that matches is 16. But because the vertex was at -2, that distance 2 times in the negative direction is an x value of -4. And you can double check that with a graphing calculator, such as Desmos. That's my favorite, or whatever you want. But there it is. There are 5 points. And we were able to do that quickly because we identified vertex form. I'm sorry, vertex form. We identified X intercept form, and we knew what to do with the vertical scale, how to deal with it now. Okay, next we have 2 more examples so that you can test your skills and see if you want to get ahead of myself. Pause it and then check with me now. Let's do it. So my first question to myself or to students is, when I'm working with them, what would you identify this as? What's easier to find? What's the most convenient thing to find in this form? It is the vertex. So that's where I will begin now. Rather than x-intercepts as the last problem, the vertex is going to be when the something square is equal to 0, we get a negative 100. And x is equal to 0. I'm sorry, the something square is equal to 0 when x equals 3. Vertex is 3, comma, negative 100. And I should have given myself more space. 3, negative 100. Give you more time to think how. If you forgot, how can we quickly go from here to here? All right, next, in whatever order you want, I would probably start with x-intercept. So x-intercept, what do we know about all the x-intercepts? Is when the y value is 0. So therefore, we would get this equation, all right? Take your time if you need to, but I'm going to go to this step. 100 equal to, not 106, 100 equal to 4 times something squared. What's the something inside? It's a x minus 3 term. Notice that I went from this equation by adding the 100 to both sides once this was a 0, if that's what's confusing you. All right, next thing we want to do, we just want something squared by itself, not a 4 stretch factor. Remember, this 4 is stretching the y value vertically, so we want to isolate the something square and therefore deal with its times 4. So how do we undo multiplying by 4? Divide both sides by 4. What happens when we divide 100 by 4? We get 25 equal to the something squared. The something squared is still an x minus 3 term, and from here, hopefully you can do x equals, not negative x. That looks kind of weird. We're going to get that x equal, take your time. It's going to be a positive 3 plus or minus 5. So that means the 2 points are 3 plus 5. 3 plus 5 is 8 comma 0. And the other point is 3 minus 5, negative 2. If my pace is a little too fast for you, then go back or pause. Do what you need to do to understand it. It's not a race. It's that you understand it, not that you beat me. All right, then I would find out y-intercept and then start plotting points at the end. So, because so far we have 3 points. Y-intercept occurs when, there we go, when x equals 0. So therefore we know the y-intercept is going to be 4 times negative 3 squared minus 100. And be very careful. I'm going to give you some time so that you simplify, but here's what I would suggest. Don't multiply these 2 numbers and then square. That's absolutely incorrect. You have to square what's inside first and then multiply by 4. So the x value is 0. Let's check together. The y value should be a 64. Or negative 64, I'm sorry. All right, I think that's correct. Double check yourself. It is. Remember, even though you're squaring the negative 3, this is going to be 9 times 4 is 36. Yep, that should work. Okay. So what I'm going to do now is just start plotting these points and then connecting the dots. Vertex is when x equals 3. So somewhere here, somewhere along here, this is our line x equals 3. Here's our lowest point. It is 3 comma negative 100. And then we have 5 units to the right of 3. It's going to give us an 8 comma 0. And 5 units to the left of 3 is going to give us a negative 2, 0. And like I said, it's gonna make some nice parabola. It's just connecting these dots now and putting the pieces of the puzzle together as we've done many times before. And you're probably having an easier time doing this on paper. We already calculated this point. It is 0, negative 64. I'm like 99.9% sure this is correct, but I always say this, if this is incorrect, at least the concept was right, you know? So in case I ever make a mistake that I don't catch, that's what my defense will be. Is that, oh yeah, I might have made a small mistake, but I'm doing this all in my head. I haven't worked these problems out ahead of time. I'm doing them live just so you can see what my actual natural reaction is when I see them, rather than following a script. Matching point, see how I went on this rant to give you more time to think about the y-intercept. That's a point of symmetry, or the matching point. What matches is the negative 64, the y value, and the distance of 3 2 times to the right is 6. And it should look something like that. Look at that, man. That's a great sketch of this really complicated looking thing up here with a vertical stretch of 4. We're doing some pretty advanced parabolas, believe it or not. I mean, it looks easy because we're making it look easy, but this is advanced. A lot of textbooks and teachers will have their students make a table of values, use things like negative b over 2a, and then sometimes it's not in the correct form. And you know, it doesn't foster thinking. So that's what we want to do. We want to apply good thinking to make these problems look easy rather than difficult. They're very simple, but they just look really hard. But only because we're taking the smart approach. Oh man, that's enough of me talking about how smart we are. But it's a good thing. Let's move on. Last form we haven't used, and this is the one that's the most difficult. That's why I always write it at the end. What's the form that you identify? It's the Y-intercept form or standard form. All right, if you prefer Y-intercept form, so do I. So that's why I'm going to start with the Y-intercept. Y-intercept is when x equals 0, and look how beautiful this happens if you've never seen it before. 0 squared plus 32 times 0, so 0 plus 0 is 40. The answer was right there the whole time for Y-intercept. That's the Y-intercept, the C term. All right. Easy point. No thinking, pretty much. We got that for free. All right, so next thing I would probably try and do is, this is the hardest part, but it's worth doing it because it's the most, I think it's the most important part of this problem. It's finding the x-intercepts, and that's when y equals 0. So we're gonna have to do a lot of factoring here, and that's why we spend so many videos and so much time in factoring techniques. So we have that 0 equals negative 8 x squared plus 32x plus 40. And our thinking when we see equations like this, we always ask ourselves, is there a greatest common factor? Is there something they all share in common? It's not a variable of x because this one doesn't carry it, but it's something that you see. Hopefully it's and the reason why I chose this problem is if you said it was 2, then you're way off. If you said it was 4, you're way off. If you said it was 8, you're getting a little bit closer. But the most important thing is that negative. So the GCF should not be just the 8. It should be a negative 8. If you picked anything other than negative 8, then go back and figure out why this is. And there's a lot of videos to help you with that before. That just means you probably skipped them. So this should become negative 8x squared minus 4x, and then minus 5. Double check that. Positive divided by a negative, it's a negative, and a positive divided by a negative, negative. So therefore, we're going to try and factor this completely. It's not fully done. The inside part doesn't have a greatest common factor anymore, so we're going to look for the product and some ideas. There are two numbers that can multiply to a negative 5 that can combine to a negative 4. It's got to be some form of 5 and 1. Only if we have negative 5 and positive 1. Double check that. So we know that the x-intercepts are going to be negative 1 comma 0, because remember the y value was 0, and 5 comma 0. We have y-intercept. We have the two x-intercepts. Let's start plotting some things then. So we have negative 1 and 5 comma 0. Well, that looks like 8, 5 comma 0, and -1 comma 0. All right, next. Y-intercept I'm probably going to plot last because, again, if it doesn't fit my vertex, then I don't want to be doing any more erasing. The reason why these two are the most important is this will help us find the line of symmetry and the vertex, all right? That's why they're so key, and we spend so much time working them out with the factoring techniques. And hopefully at this point you can see the value of factoring. This is a very powerful technique in this course because there are more difficult ideas coming up. Besides, if you thought this is difficult, there are more difficult quadratic techniques coming up. One more actually, and that's it. But it's more difficult and advanced than this one. So anytime you can factor, you should be so happy and thanking the quadratic gods that they gave you a better factorable problem. All right. So we know that the midpoint is 5 minus 1 is 4, x equals 2. And we know it's a parabola that curves downwards, all right? So also check that. Let's figure out the vertex. Vertex occurs for this particular quadratic when x equals 2. Let's do some substitution here, and we know their y value of the vertex is going to be, I would not have an easy time plugging it into here. I prefer the factored form. That's why factoring is so powerful. Again, I would much rather plug in a 2 to this expression than to this expression above. No way. I'm doing that. So let's go ahead and do -8 times something times something. When we substitute a 2, what is 2 plus 1? It is 3. Look at that. That's much easier. And then what is 2 minus 5? It's -3. And when you substitute this in whatever order you want, we get a positive 72. So therefore, the point should be written as 2 comma 72. And it should fit our picture. If it doesn't, something's wrong and we got to go back and fix it. So here is 2 comma 72. And it looks like it fits our picture very nicely. And our y-intercept is 0.40, so why not? Look at that, fits our puzzle very nicely. Oh, I don't like that. That didn't curve almost. There we go. Let's fix that. Should be more something like this. There we go. So that we can think, oh man, I missed it. Because that was a good start. There we go. I'll take that. It could have been a lot better. But there it is. That's the main idea. And we already know this point as, we can label it as 0 comma 40. And from there, we can figure out its corresponding point of symmetry, where the y value of 40 matches. It's the matching point. And a distance of 2 twice in the positive direction gives us an x value of 4. There it is. Very advanced idea here. Just like everything from here, it's going to escalate from here in terms of your experience and expectations to know. But look, even something this advanced, if we knew the easy route, this looks not that doesn't look that difficult. This looks like the easiest route. Trust me, there are more difficult ways of doing this that are way more boring to understand anyway. So that would be the end of this practice, and I promise you from here on, everything that we did in the last like 20 videos is for the next 15 of them. It's gonna make sense why we spend so much time the last 20 videos for the next 15 or 20 videos that are coming up. All right, so go enjoy the rest of your day, and I hope that you hear me more asking you more questions about math in the next few videos. All right, bye-bye.